My dear friends, welcome to Rajashekar classes on Applied Data Science with Python. This is lecture number 278. In this lecture, we will try to understand how to determine right K or appropriate K in kNN. In the previous lecture, that is in lecture number 277, we learned what happens as K changes. That is, for K equal 1, 2, 3, K may take values from 1 to n. I discussed 3 cases: K equal to 1 case, K equal to 5 case, K equal to n case. We understood concept of overfitting. I already discussed basic concept behind overfitting and underfitting. As I told you in that lecture, we will try to understand its mathematical interpretations in my future classes. Now we have a big data set, capital DN. Let me say my data set size, let me say my big data set is DN, isn't it? This DN is broken up into 2 data sets. First data set, let me say this is dtrain. There is another data set, let me say this is dtest. We broke it randomly. Let me assume, let me assume 70% of data is in dtrain and 30% of the data in dtest. Now we will try to understand how to determine K. I use my dtrain data. Let me write like this. Let me say this is dtrain data, otherwise I can say train data. Let me say this is accuracy on dtest. Let me assume like this. I use my dtrain data. Now on dtest data, I say what is the accuracy. What is the accuracy on dtest? Because my dtrain, what I am using, my training data, if I take, let me take K equal to 1. I want to see the accuracy. We saw what accuracy means. Just refer lecture number 273. In this particular lecture, I discussed about accuracy of kNN. Accuracy basically number of points that are correctly classified by, let me repeat, accuracy basically means number of points that are correctly classified by total number of points. This is the number of, I can say accuracy means number of correctly classified points. Number of correctly classified points by, divided by total number of points. This is accuracy. I already discussed what is accuracy in lecture number 273. I request you to go through that particular lecture. That's what is accuracy. Now I could say I will take K equal to 1. Let's assume I take K equal to 1, dtrain as my training data, and I take each point. I take, what is my training data here? Training data is dtrain. Dtrain is training data. Dtrain as my training data, and I take each point in test data set, that is dtest. How do I get accuracy on dtest? I take each point in D test and I try to predict the label. My D test is also contain pairs like, what is my D test? D test is just like pairs xi comma yi such that xi belongs to Rd, yi belongs to 0 comma 1. This is our D test data set, isn't it? It's an ordered pair xi comma yi such that xi belongs to Rd, yi belongs to 0 comma 1. Let me say I equal to 1 to, let me say, n test. N test means number of points in my D test. So it has the pairs. So I can give each of these xi's to make my query point. Let me say xq equal to x1, xq equal to x2, xq equal to x3, so on. I can say xq equal to xn test, isn't it? There are n test points because I have n test number of points here. For each of these I use xq. I will get yq corresponding to this one. I will get some yq corresponding to this one. This yq I will compare with y1. This yq I must compare. For x1 I have y1. I must compare this with y1. If yq is y1, that is correctly classified. In similar manner, for this xq also I will get yq. If this yq is equal to y2, this is correctly classified, isn't it? I can say if this predicted one is matching this y's, y1, y2, so on yn test, I can say they are correctly classified. If both don't agree, means if you were let me say xq equal to x2, this yq is not equal to y2. If they are not, if both don't agree, I will say it is misclassified. We saw this on how to compute accuracy. This I already discussed in lecture number 273, how to calculate accuracy of kNN. Please refer that lecture. One measure on how good your algorithm is, accuracy is useful to measure algorithm's performance. Let's say for k equal to 1, I got accuracy. Let me assume I got accuracy something like 0.65, isn't it? Let me assume. When my k increases from 1 to 2, what happens? Let me take D train and I'm calculating accuracy. Let me say now I'm getting 0.80 and so on so forth. Let me say I'm taking k equal to 3, same D train, I'm calculating accuracy. Let me say I'm getting 0.86, isn't it? D train, let me assume like let's say using same D train, my accuracy is 0.86 and so on so forth. Now let's draw it. Now let's draw on x-axis. Let me say like this. Just see this particular diagram. What I am doing on x-axis, I am taking values. Whose values? K equal to 1, k equal to 2. Just see. I am plotting this graph. What is this graph? Let me say like this. These are values of k. K equal to 1, 2, 3, 4, 5, 6, 7, 9. So on, what is the final value of k? K equal to n. K equal to 1 to n. On x-axis, I am taking values of k. On y-axis, I am taking accuracy on test set. On x-axis, I will take my k values 1, 2, 3, so on n. On y-axis, I will take accuracy on my test set. Typically what happens is as k increases, higher the accuracy, better the one. Higher accuracy. What is the maximum value of accuracy? In lecture number 273, I discussed maximum value of accuracy is 1, minimum value is 0. Let me say this is highest accuracy is 1 and lowest accuracy is 0. It always lies in between 0 and 1. So what happens is, as k increases, typically, not necessarily, always as k increases, your accuracy, just say as k increases, your accuracy is also increasing. Typically, as k increases, your accuracy will also increase, and slowly, it will deteriorate as you reach k equal to n. Slowly it will deteriorate as you reach k equal to n. So your accuracy changes, typically, not necessarily always. Then you say where I am getting highest accuracy. Let me say this is the point. Let me assume like this. This is somewhere here. Let me say this is highest accuracy. Let me assume like this. Let me redraw it. Maybe somewhere. Let me assume this is a peak. This is a peak value. Let me assume this number, this particular number is 7. What is this corresponding this one? Let me assume this is something like 0.96. Why? Because its maximum value is 1, isn't it? Then you say I'm getting highest accuracy. Let me assume this is 0.96. As highest accuracy, maximum value is 1, minimum value is 0. Let me say the value of k, I am getting best accuracy. Let's assume this corresponding k value, I am assuming, just I am assuming that corresponding k value is, let me assume 7, isn't it? Then I will say k equal to 7. Then I will say k equal to 7 will give me best accuracy on my, it will give me best accuracy on my D test. When use k equal to 7 gives me best accuracy on my D test when using D train, isn't it? When you are using D train as my training data set. This statement is perfect because it gives you the highest accuracy on D test. While using D train as your training, now you can go and say at the end of this, what you have to find? At the end of this, you could say you can use k equal to 7 because it gives me highest accuracy on test data set. Let's take this problem of Amazon Fine Food Reviews. For Amazon Fine Food Reviews, I will use kNN. I will use for Amazon Fine Food Reviews, I will use kNN or 7NN using my training data, and I get a performance. I will get an accuracy of 96%. Seems logical. There is one problem with this. Using D train and 7NN on Amazon Food Review dataset, I got an accuracy of 96%. It's almost right. There is a small problem with this statement. What is the objective of machine learning? We are going to very fundamentals. We are going to first principle, the very basic. What is the objective of machine learning? The whole objective of machine learning here is, let's not forget this. You are given a data set dn. You do whatever you want. You learn a function f. Using all of the data for me, I have a data dn. By using that function, I must learn a function f. That's what I discussed in my previous lectures. Let's assume what I have done here. I have broken up my dn into two parts. That's what I did. We have broken up this dn into two parts. One is dtrain and another one is dtest. I have broken up my dn into two parts. Once you learn the function, I want 2 outputs using this DN. This problem I will discuss in my next lecture, that is in lecture number 279. Time being, just understand how I determined K. How am I taking? Just go back and see. Just in my previous slide, what I did, there is something like for K equal 1, K equal 2, K equal 3, I am considering D-train and I am calculating accuracy on D-test, and I am plotting all these things on a graph. Once if I plot this graph, what happens? I am finding this let me assume this highest accuracy is 1. Let me assume this is 0.96. Corresponding K value I am identifying. This is the optimal K, this is the better K, this is a perfect K, this is suitable K. As I told you, we have some simple problem with this approach. I will discuss that simple problem in my next lecture. Thank you very much.